privileged to welcome once again all the participants to day two proceeding of the conference, Integrated Water Management for Sustainable Growth, Policy Reform and Navigating Regulatory Challenges. Yesterday, we had wonderful session taken by esteemed experts. We would once again like to thank all the participants for their active participation and request the same for today's session as well. There is a little change in program schedule. Shri Sushil Kumar from Government of Himachal will not be able to join us due to urgency on work front. So we have requested Shri Ashok Kumar, Principal Consultant, for presenting a case study. So without further delay, let's start the third technical session of the conference. We have total 4 presentations. First by Dr. Sanjay Rana, Managing Director, Parson Overseas Private Limited. Second by Shri Ashok Kumar, Principal Consultant. Third by Mr. Alok Jain, Mentor and Advisor to IMV Solution and former Vice President at Wipro. And fourth by Dr. R. Krishnan, former Superintending Engineer, PWD and former WRM Specialist, TINIAM Chennai. And sir will be presenting online. So now I request Sanjay Rana sir to kindly please come to the dais for the presentation. Yes.
As a presentation. Noted. Good morning. It's absolutely a pleasure to be here and talking on this very important topic where we are going to talk about subsurface intelligence in water infrastructure. Thanks to CBIP for this opportunity to present this. And I'm going to talk about a technique called geophysics, which is not very widely known or understood, but holds a very, very special position when it comes to investigation. So just a quick starter. How many of us have heard of geophysics? Raise of hands. Right. And how many of us have used geophysics? All right, great. So I can start right from the scratch. Okay, because very few hands only. So before I start, a very brief introduction of the company which I represent. It's Parson. Parson is a geophysical company. That's what we do, geophysics. We are having all the required certifications. And we are the largest engineering geophysics company in the country, on the way of becoming one as largest in the Middle East. So, but more than that, more than the people and turnover and all, we take great pride in the fact that we have brought various new technologies in the country from time to time. Right from when I started after leaving my atomic energy job, we brought GPR right in '96, and then there's a list there. I'm not going to go through any list here. Idea is that this is what we take pride on. And our main strength is, of course, our people who are highly experienced and they have been working with us in all the tough terrains. We are an Indian multinational, so we have offices in India, we have office in Bahrain and Saudi Arabia, and in 2022 is the last office we opened was in Singapore. So that is our expansion right now, and we are working in more than 14 countries around the world. I'm a geophysicist by profession. I graduated in 1990 from University of Roorkee, which is now IIT Roorkee. And initial 5 years, I was working with government. So I was with the state government, then moved on to atomic energy. And 95, I decided to do something different and start this company in near surface geophysics, where geophysics was not being used at all that time. So it was a business with zero market. So my initial years were all about training, telling people what geophysics can do for them, and gradually building on that. And thankfully, today it is very well accepted even in engineering projects. So that gives me a lot of satisfaction. Since then, I've been involved in a number of projects. I'll not go through all this list. I'm also deeply involved in standards and codes, including BIS, where you're smiling. Reminds you of something?
Actually, I have part of BIS and standards and codes.
Right. You're not in any of our committees, right? We are not together. Okay. I'm more in geophysical science. Your smile was very evident. Okay, so BIS, I'm working on 5 codes right now, Sesame, electrical and all that. IRC, we have written a code on bridges there. Tunneling Association of India, I was just talking to Dinkar sir. We wrote about tunnels, one code, guideline for geophysical investigation of tunnels, and it was quite some time back, but yet to be properly launched, so to say. INDST team. So these are the codes which have been authored by me. Now, coming to the topic after this brief introduction, when we talk of integrated water management, it basically our aim is to balance competing water needs for various applications, be it agriculture, domestic, industrial, and the complete ecosystem within a coordinated and sustainable framework. So that's what our aim is. But today we are facing multiple challenges when we talk about water management. And first, of course, is climate change and extreme events. We all keep hearing about, these flash floods and things like this. And climate change is so evident that earlier with the rain, for example, whatever was happening in 3 months of time, today we have it sometime in 3 days of time. So a lot of variability, spatial variability and temporal variability. Both are creating a lot of problems when it comes to climate change. Urbanization and expanding infrastructure needs. As more and more population is moving towards urban center from rural, infrastructure needs to keep pace with that, which we are not able to right now. And that's why we are really lacking in our urban infrastructure. New dams are practically impossible to make because of space constraint, environmentalist pressure. No one wants any new dam around us without realizing the fact that there is no concept of water security without dams. So the only option we have is that whatever infrastructure has been built, we have to use that and stop them from degrading. But degradation of the existing infrastructure is another big problem. It applies to dams, canals, pipelines. And where I come in and where I feel very strongly is the inadequate early stage site characterization. There is hardly any project which does not go in cost outrun, overrun, or time overrun. A project was supposed to be completed in 3 years, we complete that in 10 years. A project was having an initial cost of 500 crores, we end up spending 1,000. This is called cost and time overrun. And most of the time, other than the problems of the administrative problems, land acquisition problem, etc., there are various classes of delay, as we call it. There's a very big class of delay, and that is what we call geological surprises, geological uncertainty. That's where we come in, and that's where I'm going to focus on. So, importance of subsurface conditions. Whenever we are doing a design, or we are, for any particular project, we are able to study the hydrology, we are able to see the topography of the area, geomorphology of the area, etc. But as important these aspects are, the same importance also goes to what is the condition of the subsurface, the underground, which is hidden from our eyes. And more often than not, that is the neglected part of the project. So understanding subsurface condition will help you, for example, assess foundation stability and seepage risk, avoid zones of weak strata, faults or cavities. And then based on the ground condition, you optimize your design for ground realities, not assumptions. See, this is one point which I always like to make. As scientists and engineers, are we supposed to assume things or we are supposed to calculate things? Calculate, measure, not assume. More often than not, we assume things. And there can't be a better example of this. I'll just, I'll spit. Sorry?
You can use that.
This one? No. They can see it, no problem. ये दिख रहा है ना आपको सबको? तो ये हमारी अर्थ, right? 6,400 kilometers is the radius, right? Now, if I tell you that I wrap a rope around this earth, one rope around this earth, okay? Simple. I'm a superhuman. I'm able to do that. And then I come back and I just add 6 meters to this rope length. 6 meters. And now I again wrap it around the earth, right? So it will be slightly above the Earth's surface because now it's longer. How much above will it be? Any ideas? Any guess? बिना फॉर्मूला के क्या लगता है? 6,400 किलोमीटर की रेडियस है, उस पे हमने लपेटा एक रस्सी को और सिर्फ 6 मीटर उसको बढ़ा दिया. Negligible, right? Few microns, correct? Anyone differs from these answers?
2 pi r dash is equal to 2 pi r plus 6. So r dash minus r is equal to 6 divided by 2 pi.
1 meter. 1 meter. It will go 1 meter above the surface. Believe me, no one will ever assume this to be the truth unless you calculate, which he said. Calculation karna
Like he
padega.
said, if you might.
Few microns, negligible, these are the answers. You can't have a better example of this. There is one more example. 30 seconds from that also. I have an A4 size paper. This is a simple A4 size paper. This is not A4, but let's say I have an A4 size paper. Okay. And I fold it once. Right? And this thickness is 0.1 mm. Right? And I fold it twice. And I fold it thrice. And I keep folding it, let's say 50 times. Okay. Now, please don't come up with your logic that you can't fold a paper more than 9 times. I said I'm a superhuman. I can fold it 50 times, right? How thick will this pile be? Any guess? Sorry? See, is it possible? This folding is 50 times. Any other guess? Right. All thankfully now you're doing calculation. Now there's the last. Believe me. इसके बाद मैं सब नहीं करूँ. 2 to the power 50, and what he said was partially correct. It is not up to the moon. It is up to the moon and back, and to the moon to the back multiple times. Okay, multiple times. This is the power of calculation and avoiding assumptions. But now let's talk about our engineering world. What are we doing? We do a drill hole here, and we do a drill hole here. Right? Generally, the spacing can be anything, 500 meters, 100 meters, 200 meters, depending on the project. In between, what is happening? What are we doing there? That is what my message is. Please stop doing that as engineers. Let's not assume. Let's do the measurement. And I'll give you the tools where we can make the measurement. So once we understand the subsurface conditions, we don't need to make assumptions. So this presentation, which I'm going to make, is going to highlight the critical role of subsurface intelligence in water infrastructure, demonstrate how these techniques offer non-invasive, cost-effective insights, and showcase real-world examples where these techniques have been used. Is it going okay with all of us? No one is bored about anything? So first of all, how we define subsurface intelligence. So just like any intelligence, right? We say that we need to get intelligence on this person. We need to get intelligence on this organization. Similarly, subsurface intelligence is systematic acquisition, analysis, and interpretation of information about the ground beneath the infrastructure using advanced geophysical techniques, or it can be geotechnical techniques also. But since we are talking of smart, so we will go in the smart way. We will not go in the non-smart way. Okay. So just like today we have moved to satellite images, we have moved to drone-based mapping, etc., etc. Similarly, so these are all surface-based. There might be certain people who will come and tell you that by satellite we can tell you satellite images, we can tell you everything. Please don't believe them. Satellite images practically are supposed to be surface, and then based on certain band of the energy which is being used, they can go little under subsurface, okay, but they cannot go 1 kilometer down the subsurface. Okay, so don't believe these kind of claims. So they give surface, and here we come for the subsurface using geophysics. And once you do that, you have the answer to your critical questions. Is the foundation material competent and stable? Are there hidden faults, casts, etc., etc.? How does groundwater is interacting with the medium there? What's the long-term deformation or leakage potential? So many things which you come to. And geophysical data and infrastructure longevity is completely interlinked, because any structure is as stable as is your ground on which the structure is. As simple as that. Okay. You cannot have a strong structure on a weak ground. You cannot put your foot on a weak strata even. If you go in a quicksand, you will go down there for sure. But in quicksand, it will not support your weight. Similarly, no infrastructure will be supported unless your ground is good enough. So without this, data engineers are designing in the dark, just like this guy there. All the design is being done practically with the eyes closed. As engineers, we don't want to admit it. That's a big problem. But most of the design is happening like this. And that is why when the disaster happens or any failure happens, we really run to find who is the culprit. Silkiara happens. Okay. Let's penalize the contractor who made that DPR, who made this, who did that, etc. But we still do not address to the core issue. Why Silkiaras happen? Silkiaras happen because we still go around doing the same way of making DPRs, doing the investigation, which we have been doing for centuries. We are not still adopting to whatever is available for us. So, very famous words of Shri Visvesvaraya when he said the engineer's first problem in any design situation is to discover what the problem really is. If we know what is the real problem, we can design for that. Okay. Just like your own body, you are having fever. You're going to doctor, he's giving you some medicine to bring the fever down. Is fever the problem or the cause of the fever the problem? Right? So once you go for the investigation, you know that you are getting this fever because of this underlying problem in your body. And then that problem is treated and fever vanishes. Right? So if we understand the problem, so problem definition, first of all, define the problem. Then investigation, so avoid assumption. So this is what is the meaning of this sentence. And what is happening is this. We are still doing the things in the same old way, using inappropriate, outdated tools. So these guys are trying to push this cart using some kind of rectangular wheels. Okay. And then someone comes and says, tools are available, use them. Don't be scared, your job is still safe. But more often than not, the answer is no thanks, we are too busy. Tell me, it happens in our organizations or not? Whenever someone comes with a new technique or new solution, we say, oh, come on, we are too busy. We have so much to do. Don't waste our time. Okay. The question you need to ask is, are you too busy to improve? Can you ever be too busy to improve? Okay. So at least for next 29 minutes, don't be too busy. So let's focus on what we are going to say. Whatever effect it makes will determine how we take it forward. And then we always talk about in any project, difficult ground condition. All of you, thankfully, sitting here are experienced people. We are not talking to students here. So whenever some problem happens, we say we met with a geological surprise. Right? That's a very common term, which now has been renamed. We call it what? Some geological condition or something like this. Now, geological surprise has been renamed recently. I heard in one of the meetings. Yeah, they just renamed. They didn't like it anymore. Yeah, adverse condition based on which they give some extra compensation to contractors and all that. Fact remains that expertise and engineering solutions are available to meet with practically any ground condition. Think about it. You're doing tunneling, okay? And I tell you with great confidence that at this particular chain edge, you are going to meet a weak strata, okay? Or a fractured zone, whatever it is. I tell you what you'll do. You'll go to that point, stop your TBM, do the pre-grouting, let the ground consolidate and then go through it. Okay. So engineering solutions are available to deal with practically any ground condition. If they can make a Burj Khalifa in Dubai, what can be a better example of engineering solution for practically any condition? Right? Dubai, look at the soil there. They have made Burj Khalifa because they had the solutions for the problems there. The problem is meeting the unexpected and uncertainty of the ground condition. So when we are doing a project, suddenly we come across this formation which we did not expect to come across. Right? So we thought we designed the entire Burj Khalifa assuming that bedrock is there at 10 meters of depth. And then we meet a sand column. That will be a problem. Right from the beginning, you know there is an infinite sand column practically. There's no problem. You design the entire thing for the sand column there. So meeting the unexpected is the problem. So that's where geophysical investigation come in picture. To very briefly describe it, because since all of you did not raise your hand when I asked if you have ever heard of geophysics, so you'll have to go through this, unfortunately, basic explanations. So you see medical images here. These are not geophysical images, but they convey the right message, what is geophysics. So just like in medical imaging, we are doing ultrasound, X-ray, MRI, CT scan, etc., to find out what is inside our human body. So what we are doing here, we are sending different kind of rays and waves and trying to create an image of the human body. So X-ray is obviously we are sending X-rays, ultrasound, we are sending ultrasonic waves, MRI is magnetic resonance imaging, CT scan is computer aided tomography, different kind of waves are being sent. And same thing we are doing in geophysics. So we are sending different kind of rays and waves inside the earth or its structure, or measuring naturally occurring fields. It can be gravitational field or magnetic field to find out what is inside the earth. Simple. So it's medical imaging, geophysics. That's how we can compare the two. So this, for example, is a shear zone in an otherwise good bedrock. These are reinforcement bars in a concrete slab. These are buried pipes in the subsurface with different road layers. These are dam investigations. So this is the complete rock interface. These are depth scale like this. So there's so many examples. I'm not going to explain the examples. Our life is slightly more difficult than medical imaging professionals. For the simple reason that everyone knows what a human body looks like. So for example, these will always be interpreted as joints. These will never be interpreted as fractures because we know that every finger has these many joints. But if there was another one here, we would have interpreted this as a fracture. So human body is very well defined. So it's much easier to interpret this data. Earth unfortunately changes every meter by meter. Earth is not that well defined. So interpretation of geophysical data is much more difficult. That's one. Second, in medical imaging, your body is available in 360-degree for investigation. So this guy is going in the tunnel. Transmitter receiver in 360-degree will be sending the waves or rays across his body. Earth is not available for 360-degree investigation. We only have one surface, and from there only we have to send the waves also and receive the waves. So our life is slightly more difficult. That's why in US, geophysicists are the most highly paid profession, more than the doctors actually. They do the most difficult job, right? So that's the only thing. Otherwise, we can really put it as medical imaging. So why use geophysics? The answer comes from whatever we have discussed till now. The first is low cost. So let's say you are you have a pain and you go to the doctor, and doctor says go to the operation theater, I'm coming, and he comes there, he cuts you open, and then he says there is nothing inside, maybe it was some gas, right? You're smiling. We are exactly doing that in our profession, unfortunately. It sounds funny, but that's what we are doing. Okay. So the cost of the surgery versus the cost of ultrasound. He should have done an ultrasound. That's low cost, rapid coverage. Today it is possible to cover hundreds and thousands of kilometers in a single day using things like heliborne geophysics and airborne geophysics. Hundreds and thousands of kilometers in a day. Continuous information, the biggest thing, the biggest point. That is, you look at this particular diagram, you have a void here, you have a limestone pinnacle, you have certain anthropological features, and we have got these drill holes. What are the chances that you'll be able to detect all these objects just based on this drilling? Statistically, 1 in 1,000 and 1 in million, depending on the spacing between your drill holes and the size of these objects, right? You cannot detect all of these just by drilling. If you do a good geophysical campaign, you can detect all these objects because you're getting continuous information, right? So again, going back to the medical example, you have some problem, you first go through ultrasound or investigations, and then based on that, doctor decides what is to be done, even if a surgery is to be done. Now, laparoscopic surgery has come. How laparoscopic surgery became possible? Because of the imaging techniques, they were able to see the problem very accurately. And even while doing the surgery, they're able to see the problem very accurately. That's how laparoscopic surgery became possible. Doctors did not insist that no, we will stick to the same open kind of a surgery system. In engineering world, we are still sticking to the same thing. Okay. So continuous information. And next point is the most important point, optimization of drill holes. That is, please never go back from this room and tell anyone that today we heard a lecture from Dr. Rana and he said drilling is out, geophysics is in. The message is not that. Blind drilling, random drilling, unoptimized drilling is out. Okay. So you have to go for drilling because geophysics is giving you only physical properties, some velocity, some conductivity, some resistivity. You still need so many parameters. You might need chemical composition. You might need C and phi values. Geophysics won't give you that, right? So drilling is needed. But instead of doing drilling like every 100 meters, every 200 meters, every 500 meters, you don't need to do that. So do a good geophysical campaign, find out exactly where drilling is needed to get additional information and just drill there. So instead of 100, you can end up drilling just 5. So you can cut your drilling that much. And your information will become 100-fold now because you have continuous information and not only discrete information. So optimization of drill holes, minimization of surprises. Again, words have been very carefully chosen. I did not say elimination of surprises. Whatever you do, there is always something which can come out as a surprise. Like I do yoga, I go running, I do jogging, I do gymming, I do everything. I don't smoke, I don't drink. Have I eliminated my chances of a heart disease? I have minimized my chances of the heart disease. Okay. So similarly, you do the best engineering practice, so you're minimizing the surprises. And of course, it is good for early stage application. As we were discussing with Singh Saab, sitting in the office down there, that what's happening in the world of geophysics, we get a lot of calls, but all the calls come in the firefighting stage. That is something has already happened, something has gone wrong, and now they want geophysicists to go there and do something. That's called firefighting. That is, you went for surgery, your body was opened up, he could not find where the stone is. So now he is sending you for ultrasound. Does it make any sense? But that is happening again in our world. That is, as firefighting, we are going there, where the stage is early stage application so that everything can be planned better. The applicable geophysical techniques, as we were discussing down there, we are using some 19 different techniques in geophysics for our applications. If you otherwise count the number of techniques available, there will be many. 29 I have counted once sitting like this. 29 geophysical techniques which are very popular for different fields. Oil and gas exploration uses very different techniques, which you don't need to use in engineering geophysics. But 19 are there. But for water infrastructure projects, the most prominent are electrical resistivity imaging, seismic refraction and tomography, GPR, MASW, PST, and hydrogeophysical tools if you go for aquifer mapping. So I'm not going in details right now. I'll show it to you in subsequent slides. Next is what are the necessary investigation? What is the right sequence of doing it? That's most important to understand. Geophysics doesn't live in isolation. It's not like when this WWW bubble came, it was I think 94, 95. This WWW bubble came when companies operating out of a bedroom had more capital than brick and mortar companies like L&T, right? So this single bedroom company was having more market capitalization than L&T at one time because they were projecting that this website is the final thing. You don't need anything else. Very soon it was realized that this WWW is nothing but a way to present information. It doesn't create anything, right? Things are still created in the factories and by people. Okay? The bubble was burst. Then came GIS, right? GIS professionals also tried to sell GIS as if that's the end of everything else. Very soon it was realized that GIS again is a way to put information together, do query on the information, and that was it, right? That is what GIS is all about. Similarly, geophysics, when we talk about, it's not something which lives in isolation. It's part of an entire process. So when we talk about investigation, it still starts with study available geological maps, study satellite images, do the geological mapping, then do geophysical investigation, always before drilling. That is the only change what has to come in the mindset. After this, we are jumping here. Geological mapping, drilling. That's the biggest mistake we are making. Before that, geophysical investigation, then drilling, and then everything else. This has to be the sequence. So one mistake we are making is this, jumping like this, geological mapping to drilling, eliminating this process. Second mistake we are making is sometimes we just combine these two. Geophysical investigation and drilling, we put it in a single tender because it is more convenient for the financial guys and contracts guy. And as engineers, our voice is the most feeble in the entire organization. We somehow don't like speaking or we are not heard. That's what we say. Whereas I say if you shout, you'll be heard, and you should be shouting. But our contracts and financial people take most of the big technical decisions also. So they combine both the tenders. That's defeating the entire purpose of doing geophysics. After doing geophysics, you need to decide how much drilling has to be done and where it has to be done. If you've already combined it and in the same tender have given the location of drilling also, then why to do the formality of doing geophysics anyway? Because it's not a tick in the checkbox, it's a process. And then, of course, so this is where we are messing it up.
Practitioner. Why they do not follow this thing?
We'll do it after my presentation. Definitely. I'll take the questions after that because I have to finish it in next 16 minutes with all due respect. Okay. Absolutely. We'll do that. So application in water infrastructure, first is PSP site investigation. Okay. Once we are talking, PSP is the next big thing which is coming up for water infrastructure. So in PSP site investigation, geophysics has a major role to play. First objective is to understand the entire geology of the dam site. Okay, to find out if the foundation is having sufficient strength, weak zones, fractures, faults, etc., etc. Second is the reservoir area. PSP projects are coming in the areas which have never seen water. There can be a lot of lineaments there which can actually percolate the water down, and your reservoir can lose a lot of water unless you do a proper investigation. So reservoir area study. Slope stability. This is a big challenge which is coming up. Reservoir you are making and how stable are the slopes? Because if slopes are unstable and the entire thing is falling, your entire project is at a risk. And then finding the construction material from the nearby areas, okay, where the adequate construction material is available. So these are the investigation objectives. I'm going a little fast because my time is limited, and these slides will be available to you. Okay. So towards the end, I'll tell you a way how you can download this entire presentation, and then you can go and read it at your comfort. That's why I put so much on text on the slides. Otherwise, it is totally against the basic principle of making a presentation. You should not have more than 5-6 lines per slide and all that. But these are not slides, they are like notes. So you can go and read these notes. And then there can be a lot of other investigation objectives, hydrological studies, foundation design, EIA, seismic hazard assessment, construction planning, and all that. So there, what methods come in picture? Seismic refraction tomography, which we talked about. So seismic refraction tomography, what we are doing is we are putting geophones along a line. We are starting these seismic waves. All right, seismic waves are, you can say, elastic waves. We can also think of them as acoustic waves. So they're created by just putting a hammer on a plate or by using a small explosive. There are various ways of initiating these waves. Okay, they travel in the ground and then they come back without going in the theory. So these are the geophones which are put along the ground, and result is this. So this is what you get as a result. So once you do a refraction, let's say this line is around 450 meters long. This is actually a dam axis. This is the elevation. So 900 meters to 800. So you're seeing 100 meter of elevation. This you can see obviously is the dam axis. And here you can see this rock line is this yellow line, 3500. And here it is. And in between the rock is missing. So it has gone much deeper in this area. So once you have got this kind of, and this is obviously the topsoil, then the weathered rock, and then the rock. So these are kind of results which you get from seismic refraction. This is a very interesting result, and that's not of yesterday. This project I did in 2001, when I had brought seismic refraction tomography in the country. Before that, we were doing seismic refraction. Even I was doing that layer-based interpretation and all that. That had its own limitation when we were talking of very small features. So I brought seismic refraction tomography, and this was the result of that. It's 2001. And this is a small shear zone within the bedrock. This is all bedrock. This yellow one is bedrock, and this is a shear zone there. And it has so beautifully picked by seismic refraction tomography. And this was for a hydropower project. That was the time when hydropower was in its peak. A lot of hydropower projects were going on. This is just 7 to 10 meters. Bad. High velocity is good. Yeah. More strength, more compaction, high velocity. As fractures happen or shear happen or the strength comes down, low velocity. Right. So that's how. So this was a zone around 7 to 10 meters. It would have been critical for the infrastructure which was planned there. and it cannot be picked just by drilling 7 to 10 meters. Whatever spacing you use, it cannot be picked. But seismic refraction, this entire profile took 2 hours in the field and another 4 hours for processing. Right now, it is becoming even faster with more computers. So, and then we interpret this data so that people can understand it. Like this is weathered bedrock interface, so soil, weathered bedrock, and then very hard bedrock. So it becomes much easier. So this is used for bedrock profile, rock quality and depth, thickness of overburden, fractures and weak zones, slope stability studies, etc., etc. So whenever we talk about strength, which is strength? Compressive strength. We talk of P wave velocity. There we talk of seismic refraction. Whenever we talk about water, presence of water or moisture, we talk about electrical method, where we are sending current instead of these elastic waves or seismic waves. Now we are sending current, and the method has improved a lot. So we are putting number of electrodes together on the ground. The latest system which has come is 120 electrodes, which we are using right now, and no theory. At the end of it, you get your resistivity distribution of the subsurface. So let's say conductive zone, more moisture content because this is associated with tree roots. So you will see very less resistivity. Rock, hard rock, very dry, high resistivity. So like this, you get a 2D or 3D representation of your subsurface. So these are electrodes put in the ground. 20 to 25 minutes it takes for the reading. 1 hour it takes to put this entire line in the ground. If it is hilly terrain, it can take even 2 hours. But the whole thing is always in hours. And then processing of data also is in hours. And this is a very good example of one PSP project where it was done on a reservoir and reservoir periphery. And the geologist who went there, he was sure that there are some lineaments in this area, and he wanted to map all the lineaments, right? And you can see the mapping of lineaments beautifully using this tool of geophysics. All these blue ones are the lineaments around the reservoir periphery. So now you don't have to assume anything. You know exactly where the problem is. Before you fill the reservoir, you know you have to treat these zones, make them impermeable so that you do not have water loss when the reservoir has been filled. This is a good example of firefighting. Tunnel project in JNK, there was a shear zone. They did 19 drill holes over a period of 3 months because they definitely wanted to know where the shear zone is. Finding a shear zone by drilling. Well, so finally someone said, oh, there is something called geophysics. Call them. So we did this profile. Obviously, took around 5 hours to do this because area was very hilly, and the 3 hours to interpret this, and the shear zone is right there. Right. So why to waste these 4 months and then do it as firefighting if you can do it early? So number of examples. This is the best example of optimization of drilling. What does we mean? What do we mean by optimization of drilling? So this is a tunnel route, and you can see it is going from some 1500 to 2000, so 1000 meter, 1000 meter from this end to this end. Okay. If you really want very good information, you will do drilling every 50 meters, 100 meters, sometimes 500 meters, whatever you are doing, right? But you do number of drilling. It was not done like that, thankfully. It's not an Indian example. Okay. So it was not done like this. So there were 2 zones which were detected of low resistivity, which meant problem. So this zone and this zone. There's another one here also. And then optimized drilling was planned. So one borehole was planned like this to cut through this zone, and the borehole was planned like this to cut through this zone to find out properties of this zone, which are giving rise to this low resistivity. Because as I said, we are only measuring a particular physical property. We are not measuring anything else. We are not measuring what kind of formation is there. So you want to find that out, do drilling there, right? But do drilling only there it is required. If you depend only on drilling, any 50 meters, 100 meters, what are the chances that you'll be able to detect this zone by drilling right over here? Again, 1 in 1,000, 1 in million, right? So this shows beautifully how it should be applied. First geophysics and then optimized drilling. This is something I experimented with in 2001 in Karnali, Nepal. Geophysical investigation across flowing rivers. By that time, at least there was no published paper on this. Okay, so I had to do it with my own imagination. So this was Karnali. Client was very, very good friend of mine. He said, "Yeah, do whatever you want to do, but give us good results." So we went, and we obviously it was fast flowing river, so we had to put an anchor rope here, and then we sat here, took the readings and all. And this is a result. So this is all river water, blue what you see, and this is the expected compact rock occurrence, which this line we had made in the interpretation. Similarly, this one, this yellow line is a rock here. This was in Talong in Arunachal Pradesh. This was river water. And all these were checked by drilling after geophysics. And obviously the results matched. That's why we are presenting these results. Otherwise, I would have hidden this somewhere. And this was a very beautiful example. A dam axis was already decided there. Since we were in that place and client was a good friend, he said, you are here for this project. This dam axis we have finalized. We have done some 17 drills here already to know very confidently where the dam axis is. But why don't you just do a investigation there? So we did this investigation. This yellow line is the rock, which they had found very nicely using 17 holes. And they just missed the shear zone which was sitting right there. Drilling just missed the shear zone which is sitting right there.
What is the
Shear zone is where your rock has gone through tectonic forces and now it's no more a rock. So it has become almost like powder. So once you start construction there, the shear zone can suck your entire project, right? So that's what it is. So this was P wave. Now, sometimes we are interested in shear wave velocity. Why? Because P wave velocity is giving you compressive strength. But there is the concept of shear strength. For example, quicksand, saturated sand, clay, weathered rock, all can have the same compressive strength of 1500 meter per second. Even water. To take water, it will have the same compressive strength as saturated sand. So same P wave velocity of 1500 meter per second. So if you are measuring just one parameter, right, P wave velocity, you will not be able to differentiate between quicksand, saturated sand, clay, weathered rock, and even water. So we can add another parameter, and that's like the shear wave velocity. Now, quicksand doesn't have any shear strength. So shear wave velocity in quicksand, shear is this, right? No shear strength. Water, no shear strength. So shear wave velocity in these formations like liquid, gas, or something like liquid or gas is zero. So as soon as we add another parameter, you are going towards more unique solution. So Remy and MES2 are solutions for shear wave velocity, which are based on Rayleigh wave dispersion curve. As I promised, no theory. And ultimately, at the end of it, you get profiles like this, and then you can interpret first layer, second layer, third layer, bedrock, etc., etc. This is based on shear wave velocity. So whenever we are talking of earthquake site response, whenever we are talking of site response to any vibration, we always want shear wave velocity. VS30. We all have heard of VS30 for sure, who are in design, right? VS30 is nothing but shear wave velocity of the top 30-meter column. Okay. That is required for earthquake site characterization. I brought this concept of Remy in the country somewhere in 2002. This is 100 meters. This is a bedrock, and this is extremely weak zone which is there. Number of examples, and this is the interpretation. So red soil, then weathered rock, and then fresh rock. This is the depth scale. So like this, you get the complete topography of your different interfaces just by doing MESW for this. Seismic tomography is another very powerful technique where you are not able to access the area from the top and you want very high resolution results. We go for seismic tomography, which is done between two boreholes or between two faces of a structure. So these are 5 holes. 1, 2, 3, 4, 5. Seismic tomography has been done between all the holes, and this fault has been detected just because a tomography has been done between these. What we do today is that whatever we get in the hole, we just join the dots like this, interpolation. You don't need to do interpolation. You have got the holes, do tomography between them, and now you have continuous information. This is the most prestigious project of seismic tomography I can talk about. I have got 3 minutes left, don't worry. Yeah, I'll take maximum 3 minutes. All right, it's here. So, all right, so this is the most prestigious seismic tomography project I have done. This is the deepest and the farthest tomography ever done in the world. That's why it's so prestigious. This was Buna Shangtu 2 in Bhutan, where a cavity had developed when the fault took place, where 11 people had died there. And the Central Water Commission wanted to know dimension of this cavity so they can plan how to fill this cavity. So the platform available on the top was just around 10 meters by 12 meters here. So all the holes were done from there. So one vertical hole, one inclined hole. And then this was a cavity which was delineated 85 meters by 60 meters, which was later confirmed by laser cameras also. So again, these are confirmed results. And then the entire planning was done out of it. In PSP, you can do seismic tomography between drifts also, which I will not talk about. Then same techniques can also be used for existing dams. Because when we are talking of water infrastructure, existing dams can be investigated using these techniques. So in dam safety, again, number of techniques which can be used for concrete dams, masonry dams, earthen dams, still in basin, canal leakage, and foundation defects. So this is example of from the dam top and the gallery, we call it L-section tomography. So we pass number of rays through dam top and the gallery. We do the interpretation and we get complete result of the dam, weak zones where they are. Today, what happens is if we observe a seepage in the dam and we try to plan rehabilitation, we just do it based on visual. We don't know what's inside there, where the bad zone is. And then we start drilling 3 meters by 3 meters, center to center, 3 rows, etc., etc. And we end up wasting a lot of time and money in that. Once you have this kind of result, you know where exactly your problem in the dam is and just treat these areas. The next intelligent question coming from engineer is, you have just told me one slice along the dam. What is happening from upstream to downstream? For that, we do cross-phase tomography between upstream and downstream. Reservoir water need not be lowered. It can be full up to the rim and it can be done. And once we do that, we see the extent of that zone from upstream to downstream. So this was showing the zone in lateral direction of dam, and now you see the zone from upstream to downstream. Very strong techniques. This can then be converted to density, and we can see what is the density left. Because of leaching, lot of material has gone. Now density has reduced. So we now in the good formation, density was around 2.6, 2.7. In this area, it has come to around 2.1. Once you have this information, you can plan your rehabilitation. You can even calculate the amount of grout that will be required to rehabilitate this dam. Number of ERI also can be used through the dam to find out the bad zones, seepage zones like this. It can be combined with SP to see the bad zones which are having high saturation and then find out specific zones through which the seepage is taking place like this. And then seepage paths can be determined through the dam. Now my time is up. Okay, and I said 2 more minutes. So now the seepage paths can be determined in this. It also can be done for stream basin. Today, what happens is we empty the stream basin to see what is the problem there. You don't need to do that. So this is an example from Bhutan. We said after investigation that this is the bad zone. And once they opened it for repairs, 2 years later, the zone was exactly where we had said based on complete non-restricted investigation. Canal seepage is another application. Almost last slide is integrating geophysics with policy and planning. It is very important, which is missing right now. Geophysics should be mandatory in TPR stages. Right now, it is not. Drilling is mandatory. Even we tell how much drilling is to be done. So people do not have any incentive to use geophysics because they already have to do this much of drilling. That approach has to go. So current gaps are most tender documents do not mandate geophysical investigation. If included, they are often vaguely defined. Government and PSU procurement often lumps geophysics under soil investigation. They'll put out a tender of geotechnical investigation, make a geophysics a part of it. Who is the owner of the project? A geotechnical company. Then they will contact 5 geophysical companies, take the lowest quote, and then go for geophysics for sake of it. It's just like a tick, checkbox. Very wrong way of doing it. Absence of standard methodology, limited awareness, budgetary allocation, etc., etc. It doesn't always work. It fails also. Geophysics. And most of the presentation when I make, someone always raises the hand. We use geophysics there, it didn't work. Why didn't it work? First is inadequate planning and survey design, wrong tool selection. You wanted to find out, let's say something where raise duty should have been done. You're using seismic for that because you just have a seismic equipment. Method lacking desired resolution, geology ignored, only single tool use. Never use a single tool. Always use multiple tools to uniquely resolve it. Technological failures, data processing and interpretation errors. This is the conclusion where we started from, low cost, etc., etc. This is your free gift. So you can take out your phone, scan this QR code, and a form will open up. You can do it now. Just 30 seconds for this. Then this slide will go from here. Okay, a form will open. It will just ask for your email ID. So as soon as you fill the form in 10 seconds, you will receive a mail with the presentation. So it will be very fast and all automated. I've written my script myself. I'm very proud of that. Thank you very much for your attention. Have a wonderful talking to you. Sure, sure. Please go ahead.
Actually, I was thinking with a geotechnical consultant kind of thing. So, as you rightly said, most of the times they go for drilling and give geophysics, confirmatory kind of proof. What is your opinion? Like, geophysics should be the basis of this thing, and geo drilling should be the confirmatory.
That is the only message I want to convey. Drilling should not even be planned. Forget about done. Before you have done a geophysical investigation, first do geophysics, find out the areas where drilling is required, and then do optimized drilling only at these places. That is the only intelligent way of doing things.
But they are coming with the pattern of how much drilling has been done. So how do we navigate this?
Someone has to change it. Raise your voice. See, as engineers, you have to go back and convince your organization that without geophysical investigation, we should not be even floating a tender for drilling, right? It has to do in the planning stage. Yes, absolutely. So I hope there is no other question. Thank you very much. It has been a pleasure talking to you all.
Next, we have online presentation by Shri Ashok Kumar, and he will be presenting a case study.
So I am audible.
Yes, sir. Yes.
Yeah. So very good morning. Certainly, study I missed the chance to present second case study. So now today, now there is time
Sir,
slot and
Excuse me, sir.
Yeah.
Could you put it in slideshow mode, sir? It's not in slideshow.
so okay. I will.
It's
Oh. Just a minute. Yeah. So now it is in slide mode.
yes, sir.
So my second case study is related to how we look for sustainable development at watershed scale. And that case study is for Usri watershed Giridih. And whatever I am presenting, that I have done research since 96 and again relooked this watershed in 2020. And this paper has been published in the International Journal of Stranger. So most of the part of that research I am presenting here, how we look. The major problem, what we face in India, we only talked about dynamic groundwater resources. But if you are looking for long-term sustainable development, you have to know how much aquifer has volume of water. Unless you will not know that volume, you can't plan for future. So the concept of this presentation is how to find out the total volume, static and dynamic volume of groundwater, and how we look at the watershed scale and how with time the watershed dynamics are changing. So this will be your overall objective of this presentation. So just I am moving forward. So this case study is from Giridih, and that is located in Chota Nagpur Plateau. And what you see here is the watershed that we call it Usri watershed, and whatever green color you see, this is satellite data. So these are all agriculture crop, Rabi agriculture crop. The Rabi crop is indicator of your use of groundwater in hard rock area. So considerably, we find a lot of agriculture activities happening during the Rabi crop, and it is located in this watershed located in Deori and Jammu blocks. So again, right now our assessment groundwater assessment unit is block wise, but watershed never follow the administrative boundary. So here is one another conflict considering watershed in place of block boundary. If we like to match your data with your CCWB. So this is located just at the plateau top from where Ganga Basin starts in left and right is your Chota Nagpur plateau, and this is Usri sub basin. The blue color is your water table height is varying. Mostly it follows in hard rock area, it follows the surface topography normally. And this is the basement. This is the basement. Basement means hard rock. From here, you can test the hard rock area. So whatever development in groundwater is taking place in this area, mostly in between water table and this basement. This is the unconfined aquifer, weathered road aquifer. So you see the beauty of this watershed, whatever development watershed scheme has been there in Jharkhand, there is considerably high density of a small, the left side image, a small, your ponds and check dams. So they have tapped very sufficient amount of surface water, but this surface water is not that only for irrigation, it is also for recharging the aquifer. So if we'll see at the right-hand side image, this is the Rabi crop acreage area. I have compared with a irrigated crop in 1996, and that was in this color. So you will find there is considerably high rise in Rabi crop acreage since when we reached 220. So a lot of agriculture activity has increased in that area for Rabi crop, and that is all by utilizing groundwater. And you find a number of check dams. So these check dams or ponds, not for irrigation, it is also they have made it under watershed scheme, development scheme for recharging the aquifer. So that is all distributed, all very especially distributed within the watershed. So this is the scenario of 1996. So the water table is very shallow. I will say it is in some area 4 to 5 meter, maximum it was 6 to 7 meter. So this is the water table, means depth of water level in that area in 1996. And there is 2 monitoring station, long-term monitoring station of CWB. One is at Theory, this red inverted triangle, and another is Jammu. Jammu is a place and Deori is place. If you see the hydrograph within the watershed, the trend is there is no decrease in water table since 1996 to 2020. And wherein in the adjoining Jammu that is coming outside of Usri watershed, there is slight decline in water level, not a very high decline, but certainly has a 2.5 meter or something decline happened within 25 years or 24 years, whatever you tell. And what the bottom is your rainfall. So all recharge to the aquifer and water level variation is directly related to rainfall in that area. If there is, actually it is not from exactly from Usri watershed, it is from Girirdi. So we expect a lot of variation, what actually rainfall is happening in Usri watershed and what it is happened at Girirdi. So that is another problem. We have very limited set of data set for even for surface water engineers or for groundwater. We have only one IMD station or gauge station that is at district headquarters, and state has also has a block level gauging station, but there that data is available, but you have to go there and collect there. And many times we find that there is a great mismatch also. So unless we do not have authentic data about the rainfall, it is very difficult to generalize. We are generalizing for entire district. So that is not, it is not going to give a good result, analytical result. Then I will not go much here. This is the topographic elevation of the watershed. So this watershed is flowing like this, and this is the deepest topography. And this is important as a basement topography elevation. So first, you have to map the aquifer. Unless you are not going to map the aquifer extent, bottom extent of the aquifer, you can't plan how much volume of groundwater you have. So in this project, we mapped the basement, that is hard rock surface and surface. So you will see the hard rock, the surface topography, and your basement topography means hard rock surface below the ground. Nearly, it is replica of each other. Certainly, some variation is there, but if you compare both of them, it looks like it is replica of what you see on the surface. Like topography, you will also observe basement is behaving like that. So that is very common in granitic, nice hard rock area or Chota Nagpur plateau. And I have number of examples compared with Hazaribagh and Ranchi. We find nearly all places the base surface topography and basement topography, we can say it replica of each other. Only it is how deep, 10 meter or 20 meter, that is the question. And this basement topography has been mapped with the use of your geophysical survey, that is vertical electrical sounding, and nearly 100 vertical electrical sounding has been done in this watershed, and it was well distributed to capture reasonably good basement topography of the aquifer. So this is how watershed looks like in 3 dimensions. You can see. I will not stay here much. So this is what I have all earlier shown. This is the depth of basement map. So somewhere aquifer is very deep, 17.5 meter. Maximum it is going up to 32.5 meter deep. So depth is very important for developing groundwater. Which means you will develop the groundwater either through dug well or through dug well cum bore well. So depth of basement is major uncertainty farmers are facing, because they are all in tribal area. They are all marginal farmer. They cannot invest much, or they cannot take risk digging a well that is going to fail. And where is uncertainty? They do not know what is the depth of where they will hit the hard rock. If they will hit the hard rock below 5 meter or 10 meter, their entire investment has gone. So that is the major risk. So this map show where we can develop the groundwater, we can dig a bore well. I will come later on, and this is saturated thickness. So this is depth of basement, and this is saturated thickness. This means this much volume of aquifer material is saturated with water. So this is the volume where we are getting groundwater. And again, we have done some satellite remote sensing, and we have mapped based on your vertical sounding and your satellite data. We have mapped the fracture zone. For a hard rock area, if you like to get a higher yield, more than what you are getting in a weathered rock aquifer, you have to locate fracture zone. And that fracture zone is in the basement surface, and the vertical sounding or resistivity survey is the best method, or I will say has a very low tech in technology to identify the fracture zone. So a number of fracture zone has been also identified in this watershed, and we have named as a fracture zone 4, 5, 6, like that. So now, based on the entire study, we have developed the zone, different zone. Zone 1, this light blue color is the most suitable zone, where we find the water table and your depth of basement both are high, where there is less risk of development. And apart from that, the river drainage, the main drainage channel is also passing through this channel. So this area is getting a considerable good recharge. And then we mapped as a zone 2. So that is second zone, where potable zone. We can say it is in a relative term. And zone 3 area is not suitable. Where basement rock is just near the surface. If you are something investing there, it is wasted of money. And even as a government scheme is something they are planning to develop in those villages located in this zone for giving a subsidy or something for drilling well or something. So it is going to fail. So this is the development plan of the Usri watershed. And so the most initially I talked about, unless you will not able to map, quantify the groundwater, entire groundwater, not only annual recharge. I am talking about total volume within the aquifer. Like you have an annual income and plus your capital, something. So here we are talking about whatever you have, entire things in your hand. Then you can plan for 20 year, 50 year. So how much we can take, how much we can deplete. And if we are going to take, then what we have to do to balance that. I will not get all the assumption. I will come to here. So how we have calculated it. Total annual usage of dynamic groundwater resources, 96 and 2020. So total it has increased nearly twofold. You can say 482 in 96 hectare meter water, groundwater were in use, and 2020 it is 930 hectare meter. And if you see the crop acreage, mostly I'm talking about the groundwater irrigated crops. It has increased from twofold, 4.65 to 9.05. So total increase, total utilization is increased twofold. So it is all increased due to your growth in agriculture, Rabi crop or winter crop, you can say. So both are correlatable. If there is increase in utilization, it is directly related to your agriculture practice. Then we have calculated how much total drainable dynamic groundwater storage is there. So in 2096, it was 3,000 around. And then in 20, it has reduced to 2,388. And then comes total drainable. This is very important. Total drainable static groundwater resources, because most of the dug well in that area is not more than 10 meter or 15 meter deep. And there is your aquifer below the base of the dug well, and that is not being utilized, and that we call it as a static resource. That resource is available, but we are not utilizing. But and so total drainable static groundwater is this much. Static groundwater has reduced because we have lowered the water table, depth of water level. Earlier it was 5 meter, and now it is suppose has gone to 6 meter. So this has also static resources has also decreased from 96 to 96 and 2020. So what is the annual utilization percentage? Earlier in 96 it was 15%, and now it has increased to 40%, you can say. And what we find, irrigation, still we have unutilized dynamic resources. The dynamic resources in 96 it was 11,000 irrigation potential of this resources. We can irrigate 11,000 hectare in 1996. That was unutilized, and in 2020 still we have around 6,000 hectare we can irrigate winter crops. So still this watershed can sustain more agriculture activity, or we can irrigate even 6,000 hectare of land with a dynamic groundwater resources. And if we look for a static groundwater resources, which is not underutilization by any means, and that can irrigate 30,000 hectare. So we have large volume of static groundwater resources, and we have potential to grow more agriculture crop. But once you are going to touch the static groundwater resources, you need to do some good practices for recharging the aquifer. Recharging the aquifer. If you are going to touch static groundwater resources, certainly you have to make a management plan to how to maintain that static resources balance, and for that you have to do a lot of recharge activity in that aquifer. So that is available, but the condition is you can utilize it. Unless in selective area you can utilize it through duct well, come bore well, but at the same time you have to implement take care of recharge there by making more check dams or recharge structures. So this is my end of presentation. If any question is there, I am ready to take up.
Thank you so much, sir. I think there are no questions. Thank you for
Okay.
joining us.
Yeah, thank you. Thank you. So may I leave now?
Yes, sir.
Okay. Okay. Thank you.
Next presentation is by Mr. Alok Jain, mentor and advisor to English Solution and former Vice President at Apple.
Presentation. Good morning. Good morning. Okay, so I'm feeling a bit out of place here because everyone is talking about water from a different perspective. Upstream, you're looking at water infrastructure, storage, distribution, public policies, a regulatory framework, and so on. Whereas I'm going to talk about water from end user perspective. Okay, you are talking about, let's say, a bucket, how to build that bucket, how to get water into the bucket, how to store that water, how to distribute that water. But my focus is going to be tiny holes in that water, in that bucket, where the water is leaking drop by drop. And that is what I'm going to talk about from the end user perspective. I'm also going to talk about the same water or the same problem as an IT professional. So my name is Alok. I was a vice president in Wipro. Currently, I am mentoring a company where managing partner is sitting here, Raghav, which is into the smart devices to manage water infrastructure. So when I look at water as an end user, what I see is that the water which is available to a lot of people, they have access to water, they don't care about it. Whereas there are millions of people, millions of citizens who are desperately needing this water. Let me explain what I mean by this. We see a lot of residential complexes around NCR. Now, if we see at the north, we have Kundli. And if we go clockwise, Kundli, Ghaziabad, Noida, Greater Noida, Faridabad. You move ahead, you see Gurgaon, Sona, Manesar, Dwarka Expressway. Hundreds and thousands of residential complexes. Each complex
has got multiple towers. And each tower has got multiple apartments. None of these apartments is less than a couple of crores. And each owner is paying around 5,000, 10,000, maybe 20, 30,000 as maintenance charges. Let's look at one tower and let's look at it from the water perspective. So let's assume there is one tower, around 50 apartments. How the water is getting supplied to these 50 apartments? There is one storage tank on the top, 30, 40, 50,000 liters. There is a society manager who puts the water into that tank. None of the owner has got any understanding or any obligation to source the water in that tank. They only use the water. Once the water is available to them, it is assumed that it would be available 24/7. Because the minute the water is not available, they're going to raise a ticket and somebody will do something. But they will get the water. They don't even pay for the water. The water charges are included in the society charge. So there is no obligation how to get the water. There is no cost to use the water. And unfortunately, because of this, there is a very little responsibility how to conserve the water. An apartment, 2-bedroom, 3-bedroom, typically will have 2 to 3 bathrooms, 1 kitchen. At an average, they will have 25 to 30 taps in any apartment. You take 1 bathroom, a shower, hot and cold, a tap, hot and cold, a wash basin, hot and cold, then you have a flush, then you have a tap or a jet, typically 10 or 12 different outlets. Our apartment has got around 3 such bathrooms and 1 kitchen, approximately 25 to 30 outlets. 50 apartments, 1,500 outlets. 1,500 potential tiny holes. And nobody is responsible for sourcing the water, and hence the conservation of water is not there. If one tap is leaking, okay, in this entire apartment, you will not get to know from which particular apartment that water is leaking, and there is no way that the society manager can close the supply to that particular apartment. Now, this is not limited to the residential complexes. It happens in the individual apartments also. The water supply is limited. It starts at, let's say, 6 in the morning. The same time when the husband or wife has to go and drop the children to the bus stop. Okay, they will switch on the motor for the bus. The water is leaking and it's a wastage. And extend it to the hotels and resorts also. Okay, no hotel can afford a dry tap in a guest room. There would be an adequate water supply made available by the admin or the facilities of that particular hotel. Any wastage that is happening gets unnoticed. So you have got lots of such tiny holes in that bucket that all of you are trying to fill. And from the IT perspective, what I see are the digital possibilities. That how is it that we can plug these holes, or at least identify these holes and try to plug few of them. Okay, before I move forward, I want to talk about 2 terms, which you would have heard about it, but I just want to come from the IT perspective. Internet, everyone has heard about it. Can anybody explain what is internet?
Answer is written here. That is what we have written there.
So can somebody explain what is that?
All the computers are connected to each other.
No.
The server is also computer. Likewise, set of computers are written there.
So it's interconnected network of computers. So you've got millions of computers in the world. You want to understand GDP of Somalia. Okay, you will go to your mobile, punch in few commands or few words, and you will get to know that. You want to know about a train from Paris to London. Go to the internet, go to your Google, okay, ask for that information and you get that. You want a flight from Delhi to Mumbai, same thing. These information is stored in various computers across the world. They are interconnected and you can access it using your mobile, which is also connected to the internet, right? Now, let's talk about Internet of Things. Anyone has heard about it? Internet of Things. What is it? Layman. In a layman terms, what is it? Anybody can explain? Always written here.
It's a sensor-based network, like where you can recognize. It's a sensor basically.
It's a network of physical devices.
It's a sensor based, it's a network of physical devices. Okay. Let me give you a few examples. You open a door of your office and you get a message on your mobile that the office door has been opened. It's possible today. The door becomes a thing and it is connected to your internet. And it is connected like the sensors that people are talking about. So there is a sensor on the door and that sensor is connected to the internet. When there is a movement, it senses that movement and sends a signal to the internet and you get a notification on your mobile phone that the door has been opened. Let's take another example. You enter the room, the light gets switched on. So there is a motion sensor, detects a motion, switches on the light. But that message is also relayed to your phone because that light is connected to the internet. So the door is a thing which is connected to the internet. The light is a thing which is connected to the internet using sensors. And it is relaying message to you on your mobile. Let's look at this slightly differently. You enter the door. Instead of sending the message to you, it sends a message to the light and the lights get switched on. So now both the things are talking to each other without human intervention. That's also possible. So this is nothing but IoT or Internet of Things, where these devices are talking to each other and each of these devices has got some kind of a sensor. Now, if we look at this from the water perspective, okay, what we see is a water tank, a water reservoir, or a water well talking to the water pump. Okay, so that's possible. When the water level is going down in a tank, it talks to the pump and the pumps get switched on. And the water level is full in that particular tank, it sends a signal to the pump and pump gets switched on. So what it does is it maintains adequate level of the water in the tank. There is no wastage. Okay. It is also possible that the pipes through which the water is flowing talks to the valve. When the water is flowing through the water, through the pipes, it is measuring how much water is flowing. And at some rule-based algorithm, it can switch on or off the valve. I'll give you some examples. So let's say there is a smart water level device. I'll show you one. That's all it is. Okay, this is the sensor. it senses where is the water, and this is connected to the internet and relays it to the internet that how much water is there. It's continuously publishing that data. And that's all it is doing. And once this data is received at a server, so this device, okay, can measure up to 2.5 meters. Now all of you are talking about multiple 100 meters. So I'm talking about those tiny holes. I'm talking about small reservoirs. So it's 2.5 meters. But I also have got a variation. If I change the sensor, it can go up till 7.5 meters. And if I change the sensor further, maybe 20 meters, 30 meters, and so on. It's doing nothing but measuring the water, where is it, and relaying it to the internet. Once this information is available, and my application, my servers can pick up this information and based on certain rules, tell the pump. Okay, that's all I need on the pump to switch it on or switch it off. No human intervention. Okay, these are very small devices and they cost in thousands. Okay, not in millions, and they can be installed anywhere. But are good way to conserve the water, avoid leakages, avoid those tiny holes. So this is my smart water plug. I can program it to say that whenever it reaches X percentage, 90%, 80%, switch it off. I don't want more than that. And whenever it reaches certain percentage, 20%, 10%, start filling it up. That's all I need to do with this plug. Then now I have got a smart meter flow. So, sorry, smart water flow. So let's say that there is a residential building. The water from 50,000 liters is going to 50 apartments. Okay, the water is continuously flowing to each of the apartments. And I can install the water flow in the inlet of each apartment. I will keep on measuring at every half an hour interval or 1 hour interval how much water is getting used. Over a period of time, if I apply AI or ML, okay, artificial intelligence, machine learning, big data analytics, I will realize in my system that this particular apartment does not use more than 10 or 15 liters of water between midnight and 4 a.m. It's possible for me to get that information. Now, if on a particular day, this system, this water flow detects that there is 100 liters of water flowing between midnight and 4 a.m., it can raise an alert that there is an abnormal activity. It could be guests have come or it could be a leakage. Okay. And it is also possible that this water flow can talk to the water valve and switch off the water supply to that particular apartment. If that apartment is locked, the family has gone on a vacation, okay, the water will keep on flowing. It will keep on leaking. But using the smart water valve, it's possible to automatically shut off the supply to that particular apartment and save the water. These equipments or these devices, not very expensive, easy to install at a micro level, at a residential level. And all this information is now available to you on your mobile. You can see in real time what is the status of each tank, what is the status of each pump, or you can also see the statistics of how much water is getting utilized at every hour of the day within your apartment. It can be done for an apartment user or it can be done by the society managers to see how the water is getting utilized and where the abnormal water is getting utilized and raise alarm or check that can I do something to avoid that leakage. I was talking to some people in the Delhi Jal Board. Anyone who's from Delhi Jal Board? Okay. Sometime back, I was talking to the people in the Delhi Jal Board, and what they told me is they spent around 5 to 600 crores per annum in Delhi just to switch on the pump in the morning. And once the water supply is over for 30 minutes, 1 hour or 2 hours, their job is to switch it off. That's all they do.
Manpower.
The manpower cost. And that's the kind of a manpower cost only. Now, if we install this and if we install this, okay, what is possible is to have a centralized control room where you have got all the tanks visible, all the pumps visible. They will automatically switch on at a scheduled time, switch off at a scheduled time, or in case the water goes below a particular level in the tank, switch it off. And couple of people, 5, 6 people can monitor it. So it's possible. So what I'm trying to convey is that using these very small technologies, very cheap products, cheap in the sense of cost, okay, we can conserve the water and fill up those tiny holes that we have got in our bucket, rather than just focusing on how to keep on filling the water or how to keep on creating those buckets. So that's all I have got. So the company that I represent is IWRM Solutions. We have been working on these products since 2018. 3 years were lost because of COVID. Entire supply chain got disrupted on procuring this. And at this point of time, we have applied for the patent of these products. It has been installed in certain facilities like Tata's and certain residential complexes. And that's where we are in our journey. Happy to answer any questions.
How much is the cost?
How much is the
Cost.
cost? Cost of, let's say this is around 3,000. Okay. This would be around 15,000. Yeah, correct. And this, if you keep on increasing the depth of the tank, the cost keeps on increasing. It's for multi-story buildings. Residents, the individual users may not be able to afford it at this point of time, but the complexes would be able to afford it.
Can it be related to market?
Oh, it's possible, yes, 100%.
Because there is
I know that. So we have our own app at this point of time. Through the APIs that can be integrated with anyone. In fact, we have already integrated with Tata's control room for managing fire tanks. Not right now, sir. We have just created this product and right now in a process of implementing it to go to the market. We have just come out of the R&D stage and the product development.
Back in the products. We develop one, then we make it. Yeah, and I think this is probably the most robust we've got now. We've gone through a multiple iterations of the product in the cycle. Now we can confidently say that this is probably useful to product.
So some of the advantages is that this can be deployed anywhere, hills, jungles, urban area, rural area, does not require any electricity. It has got a long lasting battery, is IP67, can withstand storms, dust storms, rain, humidity and so on.
at our office.
We can do that.
What is the life of this product?
Look, we have not been able to compute because it is not in the market for long, but our assessment is it will last anywhere between minimum 4 to 7 years. Minimum 1.5 years, one battery. It depends upon the consumption.
Yeah.
Can it measure the consumption of water?
Yes, once the data is with us, we can always, no, it will not be used for that. For that, you need a smart meter. No, it cannot be used for billing purpose. Flow meters are there. That is a different perspective, a different functionality. No, we are not in that space right. But that is a very small modification that we need to do.
Can we use in the network? Because all these big facilities, data,
Yes, sir.
all that, they have a big tolerance in leakage in their network. And they definitely are serious about it, like gel board, where they leak a lot of water and they are not doing anything. But these facilities want to tap their leakages. And we come in there sometime because we use geophysics to find out where the leakage is and all. But if you have these kind of, flow meters, when the time is idle, when there should be zero,
Correct.
and that time flow is detected, it means there is some leakage. So do you have any product which it,
So the water flow is in the works at this point of time. What it does is, for a period of at least 6 to 9 months, it will only observe. It will build at what we call as a big data. And then using the ML or AI algorithms, we'll be able to detect that 12 to 4, there should be only 10 to 15 liters of water flow, but now it's 100 liters, something abnormal is happening, raise an alert or do something. No. Okay, go ahead, please.
For water distribution and
No. So no, we have not gone that far right now. As I said, we are only looking at the end user perspective. Okay, but it can be scaled for that. It can be scaled for that in the sense that we can measure how much water is there in that canal at a particular, place. And the pipes that are flowing through, we can measure the flow. But nothing beyond that. Our focus has been residential, commercial, resorts, industrial complexes, office complexes, and so on, and not so much of the open water storage.
So it started off in just give a quick example. When we both got together to decide to start this, it started off as a problem and we tried to solve it. But water only comes at night in certain quarterly. That's the sun comes, punchy, all this. And every one, I mean punchy, every house has got a guard. The job is not to guard the house, to figure out the water comes at 4 in the morning. So that's how the problem in 2018. Interesting. So,
We have not gone to the market in a big
Yeah.
way. We have just come out of our development stage.
it will get some
Yeah, so our focus has been to plug those tiny holes. Okay, and we have designed this technology using certain protocols which are not widely used in India at this point of time. For example, it works on LoRaWAN. I'm not sure how many of you would have heard about it. And the LoRaWAN networks are not publicly available. So LoRaWAN is long range. Okay, it can transmit the signal to a long range, 3 kilometers, 5 kilometers, with very low power. So when you have got a mobile and your mobile, even if you're not using it, will get discharged in what, 3 days, 4 days, 5 days. Okay, but this will last minimum a year and a half, the battery, and send the signal to a long range. And since the public network is, we have got our own gateways, small gateways, which you can install wherever. Okay, the only thing that it needs the power and it will relate to our server. So even in the remote areas where there is no LoRaWAN or no other technology available, and system can automatically be placed and relay the data.
It was on public. Then we realized we went to a resort in the Hill, realized that he had a problem. He had a massive water problem. And we couldn't get the network. So we came back. We went back on food like that. Now we couldn't. Actually, we had a problem in Basantpur, for example. We had a building to wire and there was no network. Basantpur had network, Basantpur had network.
But you install one preset tower.
We'll talk to you, sir.
Okay, thank you.
Anything else? Thank you so much.
Thank you so much, sir. Next, we are having online presentation by Dr. R. Krishnan, former superintending engineer, PWD, and former WRM specialist, TNIAM, Chennai.
Yeah, what? Where's your demand?
The same way.
The water not to be. Like item. Yes, sir. We'll have to do one three of us.
And many police who are broken, so can use. Is that part living on the sense to the who is happy to have care of everything. After the. Thank you for starting. That's what they will say. Time needs it.
The daily amount of और ज्वाइस में 5 साल पानी किया चले ठीक कर और उनका नाम वो ज्वाइन कर सकता है बट वो आ नहीं रहा
कौन करो यार बात कर ली So we get it done in this one.
The big design is I mean, that's right.
It's a place we are talking to. But the rest of the happiness is not happening. So we have to find ways and means to really affect it. It's not to approximately. Yes, sir. East India. We are waiting. We are waiting. There is a 100% experience also. Same thing,
I think it will be this over the content. Let's start. Business after then back to square one. Yes.
The card will be housing we will have metal space. So I could visit maybe they could say. Network is basic.
Yes, sir. Just a minute, sir. Just a minute. We are at- Yes, sir.
Yes.
Yes.
Audible? Sir,
You are audible, sir.
are you able to hear, sir?
You are not properly.
So, good afternoon to all.
You are not properly audible, sir.
Yeah? Hello.
Hello.
Yes.
Now it's okay, sir.
Huh?
Just close to the mic, sir. Yes.
Yes.
Now you can say start
Are you
your
able to?
presentation. Yes.
Yes. Are you able to see my
Yeah.
presentation?
Not no presentation is not visible, sir. Its screen is visible, sir. You can just start your presentation. Presentation is not showing, sir. Right?
Yeah. So, good afternoon to all. I am Dr. R. Krishnan. So, I am happy to be
interact with the delegates.
Sir, your presentation is not visible, sir.
Yeah.
Your presentation is not visible. Screen is shared, sir. No, it is shared, but presentation is not. You can just open the presentation.
Uh, are you able to? Hello. One. I have shared. Hello.
The mic could do that. Where did you put mic?
Wait. Are you able to visualize?
That's where did you put mic?
Hello.
Do your face. But you recognize that one.
Sir, you can just
यहाँ से नहीं ऑपरेट कर सकते थे प्रेजेंटेशन को बहुत 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 सवाल है हम लोग प्रयास लिखना शुरू कर सकते हैं गाइड कर दो
नहीं हो गया नहीं हो
क्योंकि प्रसाद भी नहीं
अंदर कर दो हाँ असिस्टेंट ने कोई है नहीं
Read the meeting, sir. You just join the meeting, sir. No, you are able to see your presentation, but you are not in the meeting, sir. You have the meeting. Just rejoin the meeting, sir. Second thing, sir, if you are busy,
That's not possible, I think. Dr. Rana Right can request you to engage us for another 30 minutes.
Oh, sure. Just tell me how long I need to engage.
30 minutes, after that we'll have lunch.
Sure, sure. Any particular topic you want to?
Your feelings?
it will get steady with that. Right. Now you have verified the 6 case experience. The specific problem you have encountered and what measures were taken.
Let's throw in the question meetings.
30 minutes. So let's start the big case study as we say, and that I'll take it from that presentation. Our presentation. I'll take your 1 minute. एक slide पे चला जाता हूँ यहाँ भी शुरू कर दिया Thanks to the technological failure.
Surprises.
So the topic I rushed through, and it is very close to my heart. I'll go through this topic. Okay. And like we'll 1 o'clock, right? Fine. I think that's good enough time to understand this. So, as we said, India has more than 6,000 dams. All right. And many of these dams are more than 100 years old. And there are a big percentage which is now more than 50 years old for sure. And when dams are constructed, obviously they are constructed with a particular life, which is taken as 50, 60 years and something like that. The point is that we cannot afford to decommission our dams. We also cannot afford to lose our dams. And we definitely cannot afford our dams to be breached because each dam is a tickling time bomb. And when a dam breaches, the lives which are lost is in a huge numbers. And when dams are originally built, they were generally built in the area because when we talk about risk is probability of an occurrence and consequences of the occurrence multiplied. Right? If, for example, there's a breach occurring and no one is dying, the risk is very low because consequence is not there. But if a breach is happening and number of people are suffering because of that, the risk is very high. So it's the multiplication of probability multiplied the consequence. So when dams were built, they were generally in the areas which were not inhabited. Okay, so it was safe even if some problem. Now, as more and more people are coming in this world, they are settling in the downstream areas of the dam. The risk is increasing with each passing day. So there comes the necessity of maintaining these dams. Till date, how we maintain these dams again is very rudimentary, right? So since you're talking about introducing these latest technologies, how we do it today. So even dams, how we do even today is that we visit a dam, let's say before monsoon, after monsoon, look for the visible signatures of distress in the dam. And based on that visual inspection, we try to make our mind that, okay, this dam needs this treatment or that treatment. It is even worse than earlier time of when we were just looking at the pulse to understand the entire problem happening in the body. It's even not like that. It's like looking just at a person from a distance. You're trying to find out what the disease this person might be having, and then give the medicine for that, and then hope the person will be recovered from that. Okay. So we are actually in the engineering world doing things like this. And what we do in geophysics, we just deviate from there and actually go inside the dam body to see what can be the problem and then how we can treat the problem. This is where geophysics comes in picture. The first dam which I investigated was in 1998. So the best or the worst part of my life is that whatever I'm talking about is not fresh. We have been doing it for a very long time. If you do something yesterday, it's okay. It will take 1 year for people to understand it. But good thing or bad thing is that we have been talking about certain things for a very long time. And it's not that it has not been adopted, it has been adopted. But due to certain systems and resistance in the system, the rate of adoption is very slow. Okay. But not talking on that part right now. So in dam safety, the kind of problems we have are basically listed here. So anyone from the dams here or who has experience with dam, you are working with the dam, your dam owner, right?
Yeah.
Okay, where do you go? Huh?
Goa.
Goa. Okay, Anjuman Dam and all, right? You're from that dam?
I'm from the other three minor dams.
Okay.
Anjuman Dam is a friend.
Right, that's a big dam, right? Okay, good. So very good that you are there so we can understand how we talk. So dams you are looking after, their masonry dams or earthen dams? Earthen embankment dams. Wonderful. So the dams can have a lot of categories, like you can have gravity dams, you can have earthen embankment dams and all that. You can as the material of construction, you can always put them as concrete dam, masonry dams, and earthen embankments. We also call them earthen dams to make it short. And the kind of problems you have is that concrete dams can have cracks. These cracks can be right on the dam top, they can be in the galleries, etc. They have degradation or density loss. So what happens is that when a dam is built, it is built with a particular quality. And then it starts some kind of water ingress from the upstream side, which makes its path through the dam. And then over a period of time, the dam loses density wherever the water action has taken place. This is what we call degradation or density loss. A dam also can have inherent problem right from the time of construction itself. Any concrete structure when we make, we know that there can be honeycombing, right? There can be some certain voids which are left, and dam is made by pouring, concrete dam is made by pouring huge amount of concrete. Okay. And if it is not done properly, or if it is done hurriedly, there might be cases when the cavities or honeycombing happens inside the dam walls. So degradation, density loss, then water leaks. Concrete dams can have water leaks through it. So these are the various problems which are concrete dam. Similarly, masonry dam, degradation, density loss, because masonry is nothing but putting the same mason structure. You know, you can have stones, they are having the cementing material in between, and that's how you make the dam. So again, you can have degradation, density loss, water leaks. Earthen dams, of course. You can have leak path, right? So leakage path. A phenomenon of piping is very common in earthen dam. Piping is nothing but a conduit of water which forms right from upstream to downstream. Initially, it's always very small, but over a period of time, as fines keeps getting moved away, the whole thing starts getting bigger and bigger, and ultimately the dam can be breached because of that. Okay, so he's ready.
Hello.
Hello.
Yes, sir. Hello.
Sir.
No, no, sir, you are not audible properly, sir. You are using laptop, sir?
System.
It's a laptop or desktop?
Desktop.
Because,
Are you able to hear?
no, there is disturbance in your microphone, sir.
Okay. Hello.
Yes, sir.
Just a minute. In the morning we tried. Yeah. Yeah.
Hello. Hello.
In the same place. Somebody is just a minute. Somebody is calling.
No.
I joined already. Hello. Just a minute. Hello. Hello.
Yes, sir. Yes, sir.
Are you able to hear?
I'm able to hear, sir, but it's not proper actually. Maybe some issue in your microphone, headphone.
Okay.
Uh,
Is it
if you
audible?
Not properly, sir. Not properly. There is disturbance in your voice. It's breaking in between, sir.
In between breaking, eh?
Yes, sir. Sometimes maybe if you are using, sir, if you are using your laptop, then directly you can use without the headphones, sir.
Okay.
Yes.
But I am in the desktop.
If there is any other headphone is available, because now continue, sir. Now continue. Just
Are you able to hear my voice?
yes. Now it's okay, sir.
Now it is okay?
Yes. Now it's okay, sir.
Yes.
Yes, sir. So you just stay connected, sir. You can just
Yeah.
you can
I
just
will
yeah, you
share.
can just share your screen.
Yeah.
Yeah, screen is shared, sir. You just open your yes, open your
Yeah.
presentation.
Yes. Are you able to see?
Yes.
Hello?
Now,
Huh?
yes, 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 yes.
Okay.
Oh, yeah.
Voice is also clear. Eh?
Now voice is clear, sir.
Yes. Shall I continue or wait?
You
Wait
just
for a
wait,
moment.
sir. You just wait for. I will let you know when you have to start, sir.
Yeah.
Yes, sir. So you just stay connected, sir.
Yeah. Yeah.
Right, sir.
Yeah.
Just stay connected. Okay, sir. Okay.
Hello? Hello?
Hello. Hello. Yeah. Hello. 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 வா வா வீடியோ எல்லாம் காமிக்க சொல்லுவானா பாக்குறியா இது ஜாயின்ல ஜாயின் பண்ணி தான் இருக்கு திரும்ப கால் பண்ணி ஜாயின் பண்ணுறீங்களா நாங்க ஆனா ஆல்ரெடி ஜாயினிங்ல தான் இருக்கு திரும்ப ஜாயின் பண்ணுவா
And one technology of physics is going to appreciate what
Just share your
technology 7.
Yes.
There we are making the image from 40 kilometers. How much? 20 kilometers. We did, we asked them for MGC. We proved it. Because we are using the microwaves for our imaging. So whatever temperature that we set away was the depth which we are okay.
तो हम लोग से या प्लास्टिक नोके करते हैं क्रिएट
Would need some earlier mentioned specific reflection we are obviously because of the plastic. The Mexico that's going to actually check kilometers. Russians need here nuclear sources use here. Russian nuclear sources. Okay. They read up to more. That is around 48 to 50 kilometers. Yes, sir. Normal life. Hammer se
So now, Krishna with us.
So you can continue, sir, now.
Shall I continue?
Hello?
Hello. Shall I
Yes,
continue?
sir. You can just, hello?
Please continue.
Yes, sir. So good afternoon to all. Sorry for the delay. There was some interruptions. I'm happy to
So just,
hello.
sir, just use your mic properly, sir. It's not audible properly now. Yes.
Mic,
Yes.
the mic should be slightly away from your mouth.
upper side, sir.
Yeah, are you able to hear clearly?
It become worse.
Hello, are you able to hear now?
No, sir, no.
माइक को थोड़ा नीचे करो.
Now?
No, sir.
Hello,
Your,
hello.
your mic should be slightly away from your.
Yeah,
Now it's better.
No, it's
Now it's better.
and now it is okay.
Yes,
It's
sir.
okay.
Yes, good afternoon to all. So I am Dr. R. Krishnan. I am happy to share my experience related with the integrated water resource management. So under the topic that convergence of public sector for improved service delivery to the farming community. So first of all, let me thank the CBIP for giving award for our projects that to Tamil Nadu related with the integrated water resource management project as well as the participative irrigation management aspect and best irrigation system. These are the 3 awards that we have received from CBIP. So let me thank as a part of this achievement as a water resource department engineer. So coming to the subject, so water is a prime and natural resource, but its availability varies from place to place. So it is known fact for all, but the different strategies and technology are being followed in conservation, distribution and utilization of water. So increase in demand, accelerate fresh thinking and action to meet the demand. So public sectors are working on this on various disciplines, but they are working as a silos. That has to be rethink on this. So integration among the water allied sector is the need of the hour to address and to optimize water storage, distribution and usage to ensure the sustainability. So normally issues in river basins, if you see that degradation in water bodies and water pollutions and catchment degradations, coastal zone management, inter-basin transfers, and groundwater degradations. So these are the major issues related with the river basins. So Tamil Nadu is concerned, there are 17 major river basins that was divided into 127 sub-basins. So coming to this, based on these issues, water crisis, if you see that water crisis, reasons for that increase in population accelerates food grain productions. So if you compare the population before independence and present situations, you will all know that the severe water scarcity and drought in many places, dispute with the neighboring states in water allegations. If you see the Tamil Nadu, we have to depend upon the Kerala, Karnataka, and Andhra Pradesh. Like that, we have to depend on the neighboring states. So dramatic reduction in groundwater tables. So when the populations increases, normally they are going for the deeper and deeper in getting the groundwaters. Growing conflicts between water users and pollution threats. Reduction in storage capacity of water bodies. So when the population increase, per capita availability getting down. If it goes less than 500 meter cube per person per year, so it will create a critical stresses. So before reaching that stage, we have to address and we have to act on that. So who is responsible for the crisis? The result of natural factors, including floods and droughts, inadequate water resource management, increased pollution of surface and groundwater, environmental degradations, population growth, and over exploitation of the groundwater. Then who is responsible for the crisis? Inadequate efforts directed at water conservation, water use, efficiency, groundwater recharge and ecosystem sustainabilities. Is a crisis is inevitable? Yes. if we go on as we before. So we have to think on that. We have to rethink and we have to work as an integrated manner to address this. Then only we can face this crisis in a right manner. So integrated water resource management is the need. It is a process that promote coordinated development and management of water, land, and related resources. So the principle on integrated water resource management is providing adequate amount of drinking water, maintenance of quality of drinking water, participation by local community, and increase in productivity of resources what we are using, and stabilizing and protection of natural resources. These are the principle. And if you consider the key components in integrated water resource management, it includes that policy and governance, technology and innovations, public-private partnership, climate adaptation strategies, and community engagement and educations. So for this, government has taken major steps. So if Indian National Water Policy was framed in the year 1987 to optimal and sustainable water utilizations with a priority for drinking water, irrigation, hydropower, ecology, and agro industries. So that was in the National Policy 1987. So economic liberalization in the year 1990 has promoted encouraging public-private partnerships. National Water Policy 2002 is mainly focusing on demand management and equitable water distributions. When coming to that water management, there is a demand side management and supply side management. So supply side management is whatever we are getting that we have to give, and the farmers and others they have to use. But whereas the demand management, based on the need and the requirements, we have to supply. That was concentrated in the National Water Policy 2002. In 2012, so water as a vital resource for life, livelihood, food security, and sustainable development. That revision, the policy is under revisions, and a draft revisions of 2012 policy was given to the government, in which it has focused multidisciplinary approach and multi-stakeholder approach. So apart from that, Ministry of Water Resources has given a guidelines to frame a act and rules to involve the community in water management as well, especially in the area of irrigations. So based on that, almost 16 states has enacted a act for involving community in irrigation management, and also made amendments in the existing related with it. So these are the 16 states. Okay. Now, in our state, in Tamil Nadu, we have implemented a project called Tamil Nadu Irrigated Agriculture Modernization Project. It is a World Bank aided project by integrating public sector departments. So normally, government departments related with irrigation and agriculture has so far worked silos. But whereas in this project, they have integrated together as a converge together for implementing this project. This project objective is improve water management, enhance productivity and climate resilience, and increase market opportunities and agro entrepreneurs. These objectives are being achieved by implementing this project actually at a cost of 3,249 crores with the World Bank assistance of 70% for benefiting of 15.5 lakhs farming families, and area of Ayakat is 5.43. This project was implemented in 47 subbasins out of 127 subbasin under 17 river basin in Tamil Nadu. So these are in the project, there are the three major components. One is irrigation and water management, and another component is agriculture productivity enhancement, diversification, improved livelihood, market value additions. Another component is project management support. These components being implemented by integrating 7 departments, government departments, 7 departments, and 3 universities. So all the departments so far worked for the welfare of the common farming community as a silos. Whereas in these projects, so in the sub-basin areas, they have integrated together, they have converged together, they have implemented this project. This is the uniqueness because all are focusing to improve the service delivery to the same community of farming community. So this is the main focus by the each department. The water resource department has focused on tank aneckate and canal improvements and a participative irrigation management, agriculture department related with increase in high productivity, and horticulture department diversification and high value crops. TNAU, Tamil Nadu Agriculture University on technology dissemination, and agriculture engineering on construction of farm pond. Agriculture marketing department concentrated on value addition and market linkage. Animal husbandry on artificial insemination, and fisheries department fish production and additional income. So these all the departments has integrated together and they have implemented this project. So this is the component. It is a department-wise interventions. Each department what they have given for the welfare of the community in a integrated manner or a converged manners. So coming to the water source department, they have mainly concentrated on improving storage, water storage through rehabilitation of tank, annecates, and reconstruction of sluices, whatever the structures damaged in these storage water bodies, that was facilitated to increase the storage. Then improving the flow. For that, the lining and regrading of water carriers, rehabilitation of annecates. For the engaging community, they have formed 1,362 water users association, and they have strengthened already association formed under various projects in 2,774, and they have given the capacity building for the community to go along with the department for the effective implementation of participative irrigation management. Then improving water management through decision support system and a management information system, like the community collaborative water management techniques. These are the innovations that they have followed. So irrigation department has concentrated on strengthening of water bodies and repairing annecates, providing artificial recharge wells and aligning supply channels. These. Then community engagements. So for that also community was mobilized in the banner of Water Users Association with the legal affiliations. For that, Tamil Nadu government has enacted a act called Tamil Nadu Farmers Management of Irrigation System Act in 2000. Based on that, the Water Users Association are being formed under 3-tier system, and office bearers are being elected as is in the secret ballot system as per the election for assembly and parliament. These are the systems, and a capacity building for the water users association to work as a team, and they have to join involved in the water source department as a joint venture as a team to manage the waters available within the sub-basins. Then activities under the component B, the agriculture intensification and diversifications. Normally they have gone for the surface irrigation system, that micro irrigation, improved agronomic practices. Even though if they are cultivating the same crop, that paddy meat, they can go for the SRA. Presently that system rice intensification are being followed. It gives 25% of water savings and less labor work and increase in productivity. Like that, so different innovations and technology are being adapted. improving alternative livelihood through livestock and inland fisheries. So increased milk productivity, increase in crossbreed calves, improved fish productions. In the case of agriculture marketing, value additions. For that, they have formed farmers producer organizations. Almost 79 companies are newly formed, and already existing FPOs are strengthened for to the tune of 40 numbers. Then climate resilient activities, coming to smart adoption of resource conservation technology like SRI, and even the SRI that AWD, that alternative wetting and drying methods, and INM, IPM, that integrated nutrition management, integrated pest management, micro irrigations, SADNet, new techniques, new innovations are being adapted in this project area by the farmers. Then crop intensification and diverse cultivation of high yielding short duration. Even if they are going for the same vegetables, they can go for the high yielding crops, and promotion of complementary agronomic practices reduces the gap area. Then improving alternative livelihoods through livestock. So livestock infertility camps was conducted for 6,000, more than 6,000 camps, and a town was grant supplement to increase to get more milk productions. Through this supplement, they are in a position to get half liter more than the normal. So almost 1 liter increase per day. Then artificial insemination and fodder development. These are the components. Then in the case of fisheries, that more than 27,000 hectare of fish culture in the irrigations. Wherever that water source department has renovated the tanks and improved the storages, that tanks utilized for fish cultures. And apart from that, aquaculture in farm ponds. The farm ponds was created by the agriculture engineering department in the individual land holdings with subsidies from the government. And through that, almost more than 1,258 aquaculture farm points were created under this project. Apart from that, fish kiosk. So this being managed by the local farming women with a group of 5 to 6 members. So all the facilities are provided by the government under this project. Then coming to the agriculture marketing. So marketing, that new farmers producer companies are formed and supported for existing, so that they are able to give the sell the product by value additions. Instead of selling the raw product to the communities, they are making this value add products, and thereby they are able to get more income. So impact of the interventions through this project is 4.6 lakh hectares benefited by modernization of water bodies. Almost in the 43 sub-basin, 2,626 water tanks was renovated and rehabilitated. Through that, 4.6 lakh farmers, lakh hectares of farmers are benefiting. Then new and improved irrigation services are provided for 88,000 hectares. Adoption of SRI, new techniques in same paddy cultivations. So through that, 10.55 billion cubic meter of water being saved. So increase in productivity from 5 to 6.6 liters. 8.15 lakh meter, that is the calves, female calves. When we are going for the livestock, or if we get the female calves, then only they will able to get the more income through milk productions. So fish farms. So these are the benefits that has been achieved through implementation of this. This project being adapted by techniques monitored from right from the planning to completion and evaluations. That planning stage, remote sensing techniques were used for selection of tanks to be rehabilitated. In implementation stage, geotagging and web interface applications were used to monitor for monitoring that project performance information system being developed uh, from by this project, and every stages the project are being monitored, and the evaluations impact studies before and after implementation, because this project was implemented in a phased manner. After completion of phase 1, we have started to evaluate the impact assessment by engaging a third party agency. So these benefits are being, hello, these, after realizing these benefits, that sustainability has to be ensured. Sustainability, this integration has to be established. That's why we have developed a model villages, 907 model villages, by integrating 7 department and 1 university. They have developed a model. So this is the procedure how to develop a model, so that the integration or convergence made through this project has to be continued even after completion of the project. Then only the farmers will be able to get this type of service, improved service, after completion of the project. That's why in this project, one of the component was identified as a development of model villages. So I will explain about the steps that we have followed for the development of model village. So initial convergence meeting. So we have to select, and within the village, selected village, we have to convert the meeting, initial meeting, and we have to make all the officials to converge, because this convergence should not happen at the top level only. That convergence should be continue from up to bottom, top, middle, monitoring, and field. Even after completion of the project, that convergence has to be continued. For that, we have developed and we have initiated this convergence meeting and collected the baseline data from the village and created a awareness among the villagers and school children about the conservation of water and optimum. Hello? Yeah, that will come. So entry level activities like that, community water walk, then resource mapping. Along with the community, we made provision to discuss about the water resources availability within the village. They have to decide, and they have to take follow up to avoid the encroachment, everything, collect more water like that. And we have established the information center within the village itself, and a display about the various schemes in the project. And the community change management group has been developed within the village to take care of, and a capacity building training for them, and a village vision, so that we have to follow. Then key prime is water budget at a village level. They have to, before going for the cultivations, they have to assess the water availability. They have, based on the availability, they have to decide the cropping pattern that has to be followed. So this is the model of your water budget for a villages. So far, we might have heard about the financial budget. This is the uniqueness that water budget has to be prepared at the village level, so that what will be the requirement, what is their availability, how they can manage. Then wall painting, they have to develop, visualize the development of the village that has to be displayed in this. So these are the key areas that we have developed. So coming to the key learnings, convergence among water and agriculture allied departments for effective implementation. Convergence ensured at river sub-basin boundary level for effective water management. Convergence from planning to completion of the project interventions. Convergence at all level, not only top. So management level, implementation level, at the field level. Then smart monitoring of project implementation, water budget at village level, legal affiliation to promote participative irrigation management, adoption of innovative ideas and technology, climate resilience activities carried out, institutional arrangement at farm level, that is farmer producer organization and farm field school, sustainability of convergence ensured through development of model village. So these are the key learnings from this implementation of this project. So our future challenge is availability, accessibility, and sustainability on water. So the welfare of the unreached and well-beings of the future generation advocate for the managing the changes so as to reach the desired impacts and results. So for that, we have to take this as the learnings that integration is essential to safeguard and to manage the water resource.
Thank you.
I think I have received a caution. So time.
Questions, sir? Any questions?
You are a former superintending engineer.
Yes,
And
sir.
what do you do now?
I served as a water source management specialist in this project. I retired in the year 2019, and for the past 5 years, I have worked as a water source management specialist under this project. And recently, I left the project. Now, as a free line resource person for conducting farmers training. Yes.
Thank you.
Thank you, sir, for joining us.
Okay. So thank you very much for giving opportunity to share my experience in this August gather through this CBIP. I thank you very much. For my special thanks goes to the secretary and director of resource and other managers, Sakshi and Meenakshi, for inviting me to share my experience. Thank you very much.
Thank you so much, sir.
Yes.
Thank you to all the speakers for a wonderful presentation. Now we would like to present mementos to the speaker, and to do the honor, may I request please A.K. Dinkar sir to kindly present mementos to the speaker. First to Mr. Sanjay Rana. And Alok Jain. Yes, sir. As we draw this remarkable conference to a close, I'd like to take a moment to express our heartfelt gratitude. Firstly, a sincere thanks to our esteemed guests for their gracious presence and invaluable insight. Your participation has truly elevated this event. A special thanks to our distinguished speaker who delivered such thought-provoking and informative presentation. Your expertise has inspired us all and left us with much to reflect upon. To all the participants, thank you for your enthusiastic involvement, thoughtful questions, and active contribution. Your engagement has made each session dynamic, lively, and memorable. And special thanks to our sponsor, TechFest India. With that, we officially conclude this conference. We look forward to seeing you again at our next gathering. Until then, take care, stay safe, and remain healthy. Before leaving, you are requested to join us for afternoon lunch at -1 level. Thank you and goodbye for now. Presentation and photograph will be shared online.